Swayam Prabha. Digital India. Educated India.
Hello and welcome back once again to this lecture series on aluminum based alloys and metal matrix composites. So, in the previous lecture we started the portion covering the composites part of this course. So, in this lecture also our topic would be the metal matrix composites. So far we have learned about different features of these MMCs. And we have also talked about different materials used for the matrix as well as for the reinforcement. Right. So, we have seen metallic matrix such as aluminum, copper, iron, all these can be used, and for this course we are going to discuss about the aluminum based MMCs, and we have seen a variety of materials which can be categorized as organic and inorganic and so on can be used as the reinforcement. Okay. Then we started talking about the processing of aluminum based metal matrix composites. So far we have learned about two techniques of making metal matrix composites by the liquid metallurgy route. One was the star casting and second one was the melt infiltration. So we'll continue and see some other techniques of making metal matrix composites. Let us see one more technique in this liquid metallurgy route, and this will be spray deposition. So here, as the name suggests, you will have to create a spray of the matrix material. So you will have to melt the metal and then atomize it with a gas jet. In order to create a stream of liquid metal. If you look at the schematic of the process, it may look like this. So here you have the molten metal in a furnace. and there is a small nozzle over here through which it comes out, and here near the nozzle there is an atomizer which will break down this molten metal into a spray, into a liquid stream. And once this liquid metal stream is created, the reinforcement is introduced into that stream. And once this is mixed, it is deposited on a substrate in the form of a metal matrix composite. So this is the spray chamber in which all these happen. And this part goes to a cyclone in which the unused particles will be collected. So here in this cyclone, at the bottom of it, you will get the additional or the overspray powder. The process also goes by a trade name Osprey deposition. So a variety of shapes can be generated on this substrate, on the deposit, such as rounds, strips, or even clad products. But the process parameters have to be controlled properly. There is a variation of this process, but that will actually go into another category, which is in the two-phase region. Okay, so we'll talk about that in little later, but let us look at the other categories that we had listed before. So far we have been talking about the liquid metallurgy route, but there can be solid and vapor methods also, as we have seen before in the beginning. So in the solid state, powder metallurgy is the most commonly used technique. It involves mixing and blending of two types of powders, one for the metal and another for the reinforcement. and then subjecting it to the compaction process, which will give it a particular form. Or shape it into a particular form, and this will be followed by heating to high temperature and holding for a particular period, a process known as sintering, which will densify the material and generate a fully dense composite at the end of the process. But often these two steps, that is compaction and sintering, can be combined into one step by doing hot pressing. So here you fill the powder into a die or in a mold and then subject it to compression by applying external pressure at a higher temperature. Okay, so that will consolidate the loose powder into a solid product, because by application of the pressure the powder particles will be packed and compacted, and since it is done at higher temperature, sintering will also take place simultaneously and close the pores, leading to a fully dense product at the end of the process. You may also have processes such as hot isostatic pressing for better densification. In short, this is known as HIP. Hipping is a very effective technique of making composite materials into full density, because conventional compaction and sintering may not be able to close all the pores and it might leave behind porosity, and the other problem could be the clustering of the particles, right? But hot isostatic pressing applies the pressure from all direction uniformly, and therefore the packing is more uniform, and as a result of that the densification is better. Okay, and you would get a better density, a higher density at the end of the sintering process. And in solid state route there are some other methods also. For example, this high energy high rate process. In this approach, high energy, which could be mechanical or electrical energy, is applied rapidly to consolidate the metal ceramic powder mixture. The application of high energy at high rate results in rapid heating of the powder mix inside the die and leads to densification. And the high temperature and short processing time offer the advantage of controlling the phase transformation and grain growth. So if you want a material having a particular type of microstructure or a particular phase, then this could be a good method for making such materials, making such composite materials, because the short time that you have as a feature of this particular technique will prevent phase transformation or grain growth if you want a fine grained microstructure in the final product. So that is one of the major advantages of this process, that phase transformation or grain growth can be prevented so that you can get a particular type of phase or a fine grained microstructure in the material. This process has been applied to make aluminium silicon carbide composites. There is one more in this category, and that would be diffusion bonding. This is also a solid state processing route for making metal matrix composites. So here it is mostly used for fiber reinforced composites. So here the fibers are laid between two layers of the matrix, and the fibers are also held in a particular alignment by these layers of matrix. So the fibers are aligned, and once it is heated, once this assembly is heated, then these layers will be bonded by diffusion, and the fibers will be also bonded to the metal and will give rise to a composite. But these layers are generally very thin. So this technique therefore is also referred to as foil fiber foil method. So in between two foils of metals, two thin layers of metals, you have the fibers, and this assembly is bonded by diffusion when you heat it to high temperature. (6061) aluminium boron fiber composites have been processed by this technique, and diffusion bonding can also be achieved by evaporating and depositing thick layers of the matrix material onto the fibers. So instead of putting two foils like this, these layers can also be deposited over the fibers, and then the similar kind of bonding can be achieved by heating and holding at a higher temperature. So this was about diffusion bonding. Now let us also have a look at the vapor state process. Physical vapor deposition, or PVD, is a prominent technique in this particular category for making metal matrix composites. So in this process, the fibers are continuously passed through a chamber filled with vapors of the matrix material. And once these vapors condense on the surface of the fibers, a thick coating will be generated. And finally, the composite will be fabricated by assembling these coated fibers into a bundle or arrays, and then consolidating that by hot pressing or hot isostatic pressing. And the vapors are generated by the vapor can be generated by high intensity electron beam, and then it will be called as EV PVD when the vapor is generated by an electron beam. One of the biggest advantages of this technique is that a wide range of matrix compositions can be used. Right, so these are the different techniques of making metal matrix composites. We have discussed three categories depending on the state in which the matrix material is during the processing, that is liquid state processing, solid state processing, and vapor state processing. In liquid state processing, we have seen methods such as star casting, melt infiltration, and spray deposition. In the solid state process, we discussed about the powder metallurgy, which is the prime solid state synthesis route for making metal matrix composites. And then we also talked about other two solid state processes. One was high energy, high rate process, and another was diffusion bonding. And then finally, in the vapor state process, we discussed about this physical vapor deposition process, where the vapor of the matrix material condenses on the fibers to generate thick coatings, and once these coated fibers are bundled and sintered, the composite will be generated. And when the vapor is generated by an electron beam, the process is known as electron beam physical vapor deposition, or EBPVD. Okay, so these are different categories of fabrication routes for making metal matrix composites. Apart from these three states of the matrix material, that is solid, liquid, and vapor, it can also be processed in the two-state phase when both liquid and solid are present. Okay, so that is what we'll be discussing next for making metal matrix composites. But for this lecture, this is all I have. We'll take that up in the next lecture. Keep watching.